Few considerations to look at when we talk about injection of methanol. Methanol is highly preferable to be used, as we explained, as chemical inhibitors because it's cheap relatively, and it's always available. It's available in most of the industry. It has low molecular weight and it's completely soluble in water or miscible in water. But this will create further issue when you want to separate or regenerate or recovery of the methanol. If you have large quantity of hydrocarbons in your gas stream, then this means that you will lose large quantity of the methanol due to the solubility of the methanol in these hydrocarbons, as we explained earlier, and this will impose further purification costs later on. And this will be a major drawback since the refiners will also impose certain penalties or cost for the high methanol content in the liquid hydrocarbons, for example, because this will affect the catalyst that's used further in the process. Recovery of methanol, as we explained earlier, is very difficult. You cannot really separate it completely from water, and the recovery factor will be low, even if it's not with water, even if it combined or it's soluble in the heavy hydrocarbon. It's not that easy to separate them. And normally, when when the methanol, for example, is soluble or is highly soluble in PTX, which is benzene, toluene, xylene, as well. This means that both components will be lost through boiling. You cannot really separate them easily. So this means that, as a result, you can conclude simply that if your gas stream is extremely rich in liquid hydrocarbons, then it's not feasible to use methanol because you will lose large quantity of methanol due to the solubility of methanol in these compounds. Now, when it comes to ethylene glycol, when we inject ethylene glycol, for example, ethylene glycol, once compared to methanol, has few differences. It has high molecular weight, higher density, higher viscosity, higher melting point, higher cost, and lower solubility in hydrocarbon. So only one advantages once compared, or one or two advantages once compared to the methanol is its lower solubility in the hydrocarbons. Methanol has higher solubility in the hydrocarbons, which impose more restriction in the operation. Glycol is better in that situation because it has lower solubility in the hydrocarbons. So as we have learned earlier, that the D value or the decrease in freezing temperature is function of mainly the Xi, which is the mole fraction or massive fraction of the inhibitor, not the structure of the inhibitor. So we have learned already that lowering the hydrate formation temperature, or the D value, or the depression in hydrate formation temperature, is a function of mainly the fraction or the concentration of the inhibitor itself, not the chemical structure of the inhibitors in the liquid phase. Therefore, if I'm comparing methanol to glycol and I want to achieve the same depreciation temperature, this means that I need to inject more glycol in water phase in order to bind with the water phase once compared with methanol. So methanol will require, therefore, if I am having two scenarios, scenario A and scenario B, and I need the depression or the decrease in temperature in the two scenarios to be the same, I will require less methanol once compared to glycol. So normally you will require large quantities of glycol in order to achieve the same value of the D once compared to glycol, and this is once compared to methanol. So imagine this scenario, scenario A and scenario B, where this will give me dA, or the decrease in temperature, and this will give me dB. And if I want to assume that the decrease in temperature in the scenario A and scenario B are the same, this means that if I'm using methanol in A, I will require less amount of methanol than the glycol. I will need to inject more glycol than methanol in order to achieve the same effect or the same decrease in the temperature of the hydrate formation temperature. Now, once we talk about injection of glycol, we are talking about different type of glycol. We are talking about monoethylene glycol, diethylene glycol, and triethylene glycol. And monoethylene glycol normally is always preferable once compared to DEG and TEG. And why is that? Because it's relatively high, has lower molecular mass, lower solubility in hydrocarbon, which is also a positive thing, low viscosity and low freezing point. And also MEG is preferable once compared to methanol in certain cases, especially if you are dealing with brine situation, because MEG once added to the brine situation, or the situation or the condition where you have brine, it will not cause any precipitation of the salts, similar to the case when you add methanol. So if you have a brine situation, if you have a situation where you need to add the chemical inhibitors to a system where you have brines, for example, where the water has high salinity, for example, it's preferable to use MEG because MEG will not cause the precipitation of the salt. Meanwhile, methanol will cause the precipitation of the salt. Now, per unit volume of the PMG in terms of cost, per unit volume of MEG is more expensive than methanol. Therefore, it's always preferable to recover the MEG after using it in order to re-inject and using it. Meanwhile, methanol, as we explained earlier, we cannot really recover it at high percentage, and therefore it's very challenging to recover methanol. Meanwhile, for the MEG is more preferable, or it can be also done through a distillation process. Therefore, MEG can be recovered, methanol cannot be recovered. MEG is more expensive than methanol, so you need to optimize in this case. Methanol is cheap, but once you inject it, you cannot recover it. MEG is more expensive, but when you inject it, you can recover it through distillation process. But the distillation process also has its complication, especially in case when you are dealing with brine situation, or when you have salts soluble in the water stream as well. Now, glycol injection operation, from operational point of view, few things to keep in mind: that glycol must be injected ahead of cooling vessel, before the cooling vessel. If you are dealing with heat exchanger, glycol will be sprayed directly into the tube bundle instead of injecting the glycol before the heat exchanger. For the glycol water oil separation, which is talking about relatively about the recovery process of that, you need to allow residence time between around 30 minutes if the temperature is around 30 to 40 Fahrenheit. If there is no foaming or emulsion, 20 minutes of the residence time will be enough, and the separation will be done or achieved at temperature relatively high, around 100 Fahrenheit, and this is in order to promote the settling and decrease the viscosity of the glycol in order to enhance the separation process. Glycol losses could be physical losses, which is again very major losses, similar to the methanol as well, and other two mechanism, or the decomposition of the glycol as well, is another way or another mechanism for losses of the glycol during the injection. The glycol losses also might be through the other famous two mechanisms that we explained for the methanol, especially the solubility of the inhibitors in the hydrocarbons and the vaporization of the hydrocarbons during the injection. But as we explained earlier, this is more common in the methanol one, but it's less common in the case of the glycol, specifically if we are dealing with monoethylene glycol. But if you are dealing with diethylene glycol and triethylene glycol, you will get more chance for the loss of material through the solubility in hydrocarbons and the vaporization. Glycol solubility will be increased due to the increase in temperature, increase in the molecular weight, and increase in the concentration of the glycol in the aqueous mixture as well. Now, another thing that we need to keep in mind is that we need to apply, or we need to implement, something called the corrosion inhibition. And why is that? The corrosion inhibition is very important because the corrosion inhibition will affect the emulsion stability when we talk about the oil glycol water separator system. And therefore we need to prevent the corrosion. The first, or the basic technique, is to apply filters, where the filters will filtrate or will remove part of the solid material and will not allow it to pass through. And the second mechanism is to add what we call the corrosion inhibitor, but we have to keep in mind that the corrosion inhibitors might also contribute to the non-stability of the emulsion, which will cause or will result in altering or what we call challenging the oil water glycol separation process, because as we mentioned earlier, that depends mainly on the stability of the emulsion.